Okay, so this is an example of estimating your area using the sums, so using your upper and lower sums. So this is an example problem I have for you guys. You can see it looks similar to your problem in your on your Google Classroom. And you can see I have a function, I can see the graph, and I can also see rectangles that have already been decided for me. So when I count these up, I have 1, 2, 3, 4 rectangles that's already decided. That means my n is going to be 4. So that's kind of like your first thing you want to check on the graph. How many rectangles? And that's going to be your n. So this is the function that was given to me. My values are between 0 and 2, and you can see where I'm starting at 0, my rectangles end at 2. And I have 4 rectangles. So that's kind of like all the given information. So now there's a couple things we need to find first before we can find our upper or lower sum. And that's going to be your delta x, your little m sub I, and your capital M sub I. So you can see in blue down here, I have all of those already figured out. So remember your delta x or delta y, if you're finding that for a different type of problem, it's always going to be your interval, so b minus a over n. Remember, n represents the number of rectangles. Later on, we're going to use that value, but for now, we're just going to leave it in n. You can see that we found our little m sub I and our big M sub I. So those are the 3 things you want to find first. So now let's work on our lower sum. So lower sums use the little m sub I. So it's always going to be the summation, and notice how it's a lower sum, so it is a lowercase s of n, and it's going to be the summation. We're going to plug in little m sub I into our function, and we're going to multiply it times our delta x that we found. So here you can see the notation where instead of having x into my function, I'm going to plug in 2i minus 2 over n, and then my delta x was 2 over n. You can see this was my function. My function was x squared plus 1. So I have my x is now replaced with 2i minus 2 over n squared plus 1, and then still times my 2 over n. So this is where your steps could look a little different at this point, and that's fine. You just need to make sure that you're doing appropriate steps. The order of them might not make a huge difference. So for myself, I saw this 2 over n, and I just wanted to get it to the front. So I brought my 2 over n to the front. Now I'm left with, I squared my 2i minus 2, and I squared my n. I also, for this problem, I wanted to combine them, so I made this 1 rewritten as n squared over n squared. So you can see the steps that I take to combine. Just simplifying what's inside of our summation. I did not take the summation yet when I'm looking at this line right here. So if you do not take your summation, or if you're not using your formulas and you still see i's, I should still see the summation symbol. So down here, now we've used our summation formulas. So we have 4i squared. So this replaced our I squared. Minus 8i. And then we have n times n plus 1 over 2 replaced our I. And then we have plus 4n plus n cubed. Now is all algebra. So I simplified the 4 and the 6, simplified the 8 and the 2, and then just kind of keep combining as best as you can until it actually resembles a sort of like polynomial function. So you can see down here, I'm just keep simplifying, try to get things to have common denominators. It's just a lot of algebra. So down here, I distributed the 2 over n cubed to my 3 terms. I broke this first term up into 3, and then I simplified a little bit. Combine any like terms that you have, and this is the equation for our lower sum. So the reason that it's nice to keep n as an n instead of putting 4 in is if they said, now what would your estimate be when you have 8 rectangles? And you want to be able to just plug in that value to your n. You don't want to have to do the whole work again and then use 8. So make sure that you get to a nice stopping point where it pretty much resembles a polynomial function. And now we're going to plug in 4 for n. If you remember, that was the amount of rectangles that my problem had. So I'm going to plug in 4. This one had a lot of fractions, which is fine. Fractions aren't a bad thing. And I ended up with 3 3/4 as my lower sum. So that means that my area is going to be between this value and whatever value I find when I get my upper sum. So now let's do our upper sum. So when I'm looking, it's the same type of process, same setup, but now we're using a capital S of n. Notice how we're using our capital M sub I, and our delta x is the same. So my summation notation is there. It's not going away until I apply my rules. I'm going to plug in 2i over n into my function, right? Because we're asking for f of these values times delta x. So my 2 over n, I brought it to the front again, just like I did in the last problem. Kind of get it out of the way for now, and then we can kind of reintroduce it when it's easier. We have 2i over n squared plus 1. Now in this case, I did not change this to n squared over n squared, and you'll see that it's just up to preference. So I did it 2 different ways so you can see how it could be done. So squared my 2i over n, I get 4i squared over n squared. Make sure that you remember that all numbers, all variables, on the numerator and denominator get squared. That's like one of those little times where it's an easy rule to miss, and then your whole answer ends up being incorrect. So now instead of breaking this 4 over n squared out to the front, I just know that it's going to be 4 over n squared times whatever my I squared is. So this is what replaces I squared, and then I have 1, so 1n. That was like that CN rule. Here we go, back to some algebra here. Simplifying what you can. You want to make sure that you're not messing up any signs. This problem's not too bad. There's no negatives, but negatives can make a huge difference. Breaking up each piece individually so I can kind of see what it will reduce to. Once you can reduce it as best as you can, so you see down here, I finally ended up with this line, which is my capital S of n, and that looks like a polynomial function, so it looks pretty good. Now we have our value where n is going to equal 4. So we're going to plug in 4. Again, there's a lot of fractions. It's okay. You can use your calculator too. You don't need to do this out. So I plug in 4, simplify. I got them to all have the same denominator, and I resulted with 5.75, and that's my upper sum. So you really want to kind of come to a conclusion. You don't just want to do your work and leave it empty, kind of. So you want to make sure you have a final answer. So for us, our final answer means that our area is going to be between our lower sum and our upper sum. So my lower sum was 3.75. My upper sum is 5.75. So my area is somewhere in between these two values.